Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today, imagine if your coding AI could mentally run code before actually running it, like a developer who can see bugs just by reading. That's exactly what this paper explores. Self-execution simulation improves coding models by Gallil, Maimon, and Yoran, and it changes how we think about code generation entirely. So here's the problem. Most LLMs treat code as static text. They generate it, but don't truly understand what it does when executed. That leads to bugs, wrong outputs, and poor reasoning. Even worse, actually running code during training is expensive, slow, and messy. Think dependencies, environments, sandboxing. So the big question becomes, can a model simulate execution in its head and use that to improve? Here's the core idea, and it's powerful. The model is trained to predict what happens when code runs step by step. First, they build something called natural language execution traces, or NLEX. Instead of raw logs, the model sees human-like explanations. Variable x becomes 5, loop runs, output becomes this. This is key because it aligns with how LLMs already reason in natural language. Then comes reinforcement learning. The model gets a simple reward. Did you predict the correct output or not? Over time, it learns to simulate execution more accurately. And now, here's the magic. The model uses this ability to verify its own code, compare multiple solutions, and even fix mistakes iteratively, almost like debugging itself. Now let's talk architecture choices. There are two main ways this simulation is used. First, self-verification. Best at the model generates multiple solutions, then simulates each one and picks the one most likely to pass tests. Second, self-fixing, Self-RLEF. This is multi-turn, generate code, simulate, get feedback, fix, repeat. Almost like an internal loop, try, check, improve. And importantly, this works without actually executing code, which means faster training, scalable inference, and no dependency headaches. The results? Pretty impressive. Up to 43% improvement in output prediction, up to 39% boost in competitive programming tasks, and better performance even when verifying its own code. There's even something called a simulation gap. That's the difference between real execution and predicted execution, and surprisingly, it's small, which means the model's mental execution is actually quite reliable. So what's the big takeaway? This paper shows that teaching models to simulate execution is like giving them intuition. They don't just write code, they understand what it will do. And that opens the door to smarter debugging, better reasoning, and more reliable AI developers. But here's the exciting part. What if future models don't just simulate outputs, but explain why the code behaves that way? That's where things get really interesting. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.